Hello, Physics 15. How's it going? All right, coffee. All right, so we're on chapter 4, page 77. We're going to be doing problem E7. I drew a little diagram here. You folks are lucky. I'm a great artist, as you can tell. Okay, two forces. One of 70 newtons and 30 newtons act in opposite directions on a box as shown in the diagram. What is the mass of the box if its acceleration is 5 meters per second squared? This is typical. This would be, say you're pulling on this box and it's on a floor, and this would be like frictional forces, right? So if it was on ice, everybody knows it's slippery. If this was on ice, you could push something easier as long as you had, good traction. If you had good traction, and say if only the box was on ice. But if here, perhaps there's frictional forces. Okay, so what's the total force on this? It would be 70 newtons minus 30 newtons is equal to 40 newtons. Okay, that makes sense. So the net result is you're going to have 40 newtons in this direction, going this way. Okay. So mass, right? We know that our basic formula is force is equal to mass times acceleration, right? Newton's second law. So whenever we have an equation like this, right, we can solve for anything else. So here we have the force, and we're given the mass. I'm sorry, we're given the force and the acceleration, and we're going to solve for mass. So mass is equal to 40 newtons divided by 5, right? 5.0 meters per second squared. Well, so let me write out the units for newtons. It's easier that way. So a newton, of course, is simply, if it's mass times acceleration, it's going to be kilograms times the units for acceleration, right? So it's going to be kilograms meters per second squared divided by 5.0 meters per second squared. Well, the meters per second squared cancel, so the only unit left is kilograms. So 5 goes into 40 8 times. 8.0 kilograms. Okay.